So, in the previous video, we covered the Caesar ciphers theory, and if you haven't watched that, just quickly go that for a refresher. The formula is as follows. So, if we were to encrypt some plain text, the ciphertext would be the following, or it is given by the following formula. And in here, P is the plain text, and 3 is the number of shifts which we're going to apply. So this here, if this were A, we wouldn't substitute A into that position, but would substitute its ASCII value, which is 97. And if you're not familiar with ASCII, then you can look that up online. This is the ASCII table. It associates numbers to characters. And the small letter A is associated with the number 97. So in our code, wherever we have 97 or the character 97, that refers to small letter A, essentially. So we're going to use this in this formula to perform our encryption. So to find the ciphertext, so A, B, C, D, A will be replaced by the text which is 3 from it, which is D. So if the plain text is A, the ciphertext will be D, because we're adding 3 positions from A's position. So if A is at 0.97 or is associated with 97, then this would be 98, 99, and that would be 100. That will be represented over there. So this is what we're going to implement in our code. We want our code to automatically add a 3 to our ASCII numbers, then form the modulus of 26. But if you look at this, 97 upwards isn't necessarily in the range 0 to 26 or 0 to 25. In our theory, we said we're going to associate each letter with the number 0 to 25. So we have to scale it such that it comes back to the 0 to 25 range, and we will cover that in our code in a bit. So let's get right into your code. And this was just a quick refresher so that we remember what the formula is. Okay, so we're going to start off with the alphabet. We need it so that we can loop through each character that's in our plain text as well as the ciphertext. So this is our alphabet, and I'm going to use ASCII to have it. Well, another way would just be to literally type A to Z in an array or list, and that just takes time. So just to show you that this does the same thing, I'm going to print this out, and I just want to run this code to show you that it works. So if you look at this, it is a list of the alphabet, and I created that from this statement here that converts each ASCII value to a character using this function. So convert each I that is in 97 to 123 into a character. That's what that does, and it creates a list of letters, small letters A to Z. So that's the first part that I have there. Then we want to have our plain text, and let's have it in this format with space in between. You can leave the space in or out. There isn't a defined ASCII character for spaces, so we're going to cater for that in our code. Okay, so then the ciphertext is empty because we haven't started the encryption process, and the number of shifts can be any number, but the default is 3. So you can change this to 5, 6, it doesn't matter what it is, but let's keep it at the default. So default shift is equal 3. So A replaced by D and so on. So for each letter that's in the plain text, and we want to make sure that the plain text is in lowercase so that we can use these ASCII values. Remember that for ASCII values, there's a portion for uppercase letters and lowercase letters. So if we kept this P as an uppercase letter, it would not register in this range, or it would not be picked up by that small letter there. So we have to be consistent. We're making sure that the alphabet is in lowercase and our plain text is also in lowercase. So this function will help us to match that. So both plain text and the alphabet are in lowercase, and so we can start processing our plain text to convert it into ciphertext. So if we encounter a letter in the plain text, which is a space, you can see that we do have spaces here. Then we're just going to add a space to our ciphertext, so it's going to be the same. So if we have a space, add a space, or let it be a space in the ciphertext as well. Then we're going to continue. We won't do any processing from there. So it'll basically go to the next character in the plain text. So this is a for loop. We're going through each letter. So it'll go to P, then L, then E, and so on. But if it reaches a space, it's just going to register that as a space in the ciphertext as well. So we're slowly filling the ciphertext up with characters that come from our encryption. So if it's not a space, that's when we will apply our formula. So this is ciphertext plus equal to, so we're adding on to the ciphertext string, and this will require us to go to the alphabet, and from the alphabet we are going to now pick the letter or the index of the letter, that we find in the plain text from this list of the alphabet. So here's an example. If we have B in the plain text, which we don't, so let's use A, which is simple. So once this for loop gets to A, then the index which will be returned there will be 0, because that's the index of A in this list. And that was the point of having this list, so that we don't manually subtract 97 from each of the ASCII values. That is another approach which you can follow, and this is what I mean by that. So our formula is mod 26, but our ASCII values are 97 upwards. We need to scale this down so that it's within this range. One approach would be to take the ASCII value of A and subtract 97 from it so that the result is 0. Then we'd have 0 mod 26, and it would work out. And any letter from A to Z would fall between 0 and 25. That's one way to have the scaling from 96 to 123 and basically converting this to 0 to 25. That's one way. You can manually subtract the 97 from each ASCII value, then mod 26, or you can find the index of the letter in the alphabet, which would produce a number between 0 and 25 as well. So that's the same thing. So the index of A will be 0. Then after that, we're going to add 3 to it, because that's our K, or you can just put K there. Then we are going to now mod 26, and this is all that we have to do for encryption. So just a quick recap. We're looping through each letter in the plain text, and if we find a space, we're just going to add that as a space in the ciphertext as well. So the encryption of a space is just a space, doesn't change, and we're going to go to the next iteration of the loop. Now here, we're applying our formula directly. We're saying that the number which is associated with the letter, which is 0 to 25, because this scales it down to 0 to 25, added to the number of shifts which we are using, mod 26. And in the end, we're going to have our ciphertext. So once again, A would be, this here would give us 0, and 0 plus 3 would give us 3. 3 mod 26 would essentially give us what we expect to get, which is 3, right? So 3 would be 0, 1, 2, 3, and that is D. So in the alphabet, we're going to fetch 3. So this is what we're going to do. This is what it would look like. So if the plain text is A, and we apply this formula, then alphabet.index of A will give us 0, because that's the position of A in the list of the alphabet. And so that will give us alphabet 0 plus K, which is 3 mod 26. So this is the same as alphabet 3, because 3 mod 26 is just 3. So this is the ciphertext or the cipher letter which we're going to use to replace A. So that would be 0, 1, 2, 3, and that's D. So the ciphertext will have D added to it from this operation if the current letter that we're dealing with is A. So this happens for all of the letters in the plain text, and that's how we're going to perform our encryption. So in the end, when we're done performing the encryption, or when we're done stepping through each letter that's in the plain text, then we're just going to print our ciphertext to confirm that it matches what we found in our theory video. So this is what we're going to do here. And I'm just going to run that. And if you look at this, it's exactly the same as what we had in the theory video. You can also do it manually by hand if you just want to confirm, or go to any online tool which you can use to confirm your answers. So this is how you perform your encryption using the Caesar cipher. There definitely are many other complex ways to do this, but I decided to keep it as simple as I could. And if you find any other ways to do this, feel free to implement that. And with the decryption, we essentially now have this ciphertext, and we can do the same. So this would be the encryption, and we can also cover the decryption. So we can mention that in here. So let's turn this into an F string, and we can have this ciphertext is the following. So it'll just be this, and we can start with the plain text as well. So we can start up here with this. So plain text would have been plain text. Then this is the ciphertext which we got out of it. Then next, this would be the plain text which we got back. So plain text returned from encryption. So decryption. And it would be some variable. Let's use a different name. Let's call it decrypted plain text, something like that. And it's currently empty because we're about to perform the decryption process. So in there, that's what we're going to have. We're going to have decrypted plain text. So let's start the decryption process. It's essentially the same. So I believe you can do a copy and paste of this. And if you remember, it is just a negative of what we did. So now it's for letter N ciphertext, because we're now stepping through the ciphertext to decrypt it, right? And here we are adding on to the decrypted plain text. Then down here, we are also adding on to the decrypted plain text, and we're still using the alphabet to step through each letter of the ciphertext. But now in here, we're subtracting. So let's see what we get from this. I'm just going to quickly run this. And if you look at this, our original plain text was please and thank you. This is our ciphertext which we got, and we confirmed that it matches what we got in the theory section. And this is the decrypted plain text which matches what we had originally. So the encryption and decryption are essentially similar. The difference is that in your encryption, you have a plus there because you're going to the right by 3 or by k. And here you're going back. So if you have D, you're going to go back by 3, and that gives you A, and so on. So this is how you do your encryption and decryption using the Caesar cipher. If you have any questions, please let me know in the comment section. Any comments are welcome as well. Please like, subscribe, share. I'll see you in the next video where we will cover yet another algorithm.